Hello everyone. The title of this video is Expressing Square Roots of Negative Numbers as Multiples of I. Alright, and every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text, section 2.4, titled Complex Numbers. And I'm working under the heading Express Square Roots or Expressing Square Roots of Negative Numbers as Multiples of I. So, just a couple examples here, and they're taken directly from the reading, right? Examples or the try it problems or the exercises at the end of the section related to this particular objective. So I've got this written out here. All these, there's just two of them. Very simple stuff. Right? So we're asked to express each number in what's called standard form. I'll explain what this is in a second. But first we have to be introduced to something called the imaginary unit. And this is the number I. Right. Now I know it's a letter in the alphabet, the English alphabet, I get that. But in mathematics, I is a symbol for a number. And this number is the principal square root of -1. Right. Remember this is again the principal square root of -1 is this I. Because remember, every number has two square roots, one principal or a positive one, and then one negative one. All right, remember the square root of 4, 4 has two square roots. 2 squared is 4, and so is -2. Right? But when you see this symbol, whenever you see the square root symbol, that's asking you for the principal square root or the non-negative square root. Now what does this mean? Right? When they say I is the square root of -1, that means that I is a number that when you square it, you actually get a negative number back. Right? Remember the real numbers? The real numbers, when you square it, when you take any real number, positive number, negative number, and square it, the result is not negative. Can't be. So we have to dive into this new set of numbers called the imaginary numbers. Right? So there's a definition of this I, right, this imaginary unit, the principal square root of -1. I'll just say the square root of -1 instead of principal all the time. Just remember that whenever you see this square root symbol, they're asking for the principal square root, not the -1, right? If they want the negative square root, they'll throw a negative sign in front of it. All right, so the imaginary numbers, right, the imaginary numbers are all the following form. Then this is what they're saying by the standard form. The standard form of these imaginary numbers are of this form: some real number b times I, right, where b is real and I is that principal square root of -1, right, the imaginary unit. So there, this is the set of imaginary numbers. These are the numbers whose square will be negative. So an example, we already saw I, 1I. How about 2I, 2 times I? this is an example of an imaginary number. Since when you square it, or if you take 2i and square it, well, 2i times 2i would be 4 times I squared. But remember, I squared is -1. So this is 4 times -1. This ends up being -4. So 2i is the principal square root of -4, right, because of this. Another example, 3 times I, right? Again, just a real number times I is called imaginary. Now, if you were to square 3i, right, take 3i and square it, you'd get 9 times I squared. And don't forget that I to the second power, I squared, is -1. So this is 9 times -1, which is -9. That means that 3i is, the principal square root, because there's no negative sign in front of it. It's the principal square root of -9. Right? When you square it, you get -9. And in general, we're going to rewrite square roots of negatives in the following way. In general, if, say n is a positive number, then we're going to write the square root of the opposite of n. Right? If n is positive, this is negative, right? -n. We're going to say, the principal square root of -n is just the square root of n, right? Some real number times I. Right? And this is what the whole objective is about, expressing square roots of negative numbers as, some real number times I, right? As a multiple of I. So this is huge, right? This is what you got to remember from this video right here. Okay. So like you saw back here, if I went backwards with this, right, the square root of -4, I would express as the square root of +4, so 2 times I, right? Square root of -4 is 2i. We're going to see the square root of -9 again here, but this is how you should express any time you see the square root of a negative number. Think about expressing it in terms of this imaginary unit I, please. Okay. So noting this, right, the square root of -9, example 1, I'm going to rewrite as the square root of +9 times I. And make sure that the I is not in the square root. See, I cut off the square root short and then times I. Right, and then simplify. Right? Don't forget to simplify your radicals. The principal square root of 9 is +3. And again, I know that -3 squared is also 9, but once again, I'm going to say it. This symbol is asking you for the positive one. So 3 times I, or just 3i. And that's it. The square root of -9. Another way to express this number is 3i. And then how do you check this? Well, square it. If this truly is the principal square root of -9, then when you square it, you should end up with -9, which I showed down here. Right. So again, check by squaring. I'll write that here. Check by squaring, which we already did here, right? All right, and then for example 2, the square root of -24, I am going to rewrite. See, it's the square root of a negative, so this can't be a real number. This has got to be one of these imaginary numbers. Remember, the square roots of negatives aren't real. So I'm going to rewrite it as the square root of +24, right? That's a real number, times I. again, make sure that I is not inside the square root. All right, and then simplify. The square root of 24, right off to the side here, the square root of 24, remember, is the square root of 4 times the square root of 6, and the principal square root of 4 is 2. So this is 2 times the square root of 6, and then times I after. And this is it. This is it. And if you were to square this number, if you were to take this number and raise it to the second power, you would end up with negative 24. And I'll leave that to you to check that. All right, so the square root of negative 24, 2 times the square root of 6 times I. Or very often, if there's still a radical symbol, just to avoid confusion, to keep people from writing the I inside the square root, because it shouldn't be. Very often, like with other variables, I is not a variable, but you can treat it like one. Throw it in front. Say this is 2 times I times the square root of 6, right? It's still the same number, just reordered, right? So this is still imaginary. It still has that standard form where you have a real number, 2 times the square root of 6 times I. Right? That's the standard form for an imaginary number. All right, and I already showed you square root of negative 4 would be 2I, and it would work no matter what you do, no matter what square root of a negative, right? So you're doing this. The square root of a negative number will be written as the square root of the positive number times this imaginary unit I. And that'll be in standard form for an imaginary number. Great. Pretty easy stuff in my opinion, pretty simple stuff. But I'm telling you, get in the habit of it. Every time you see the square root of a negative number, rewrite it as a multiple of I. It'll make things easier for you in the long run, I promise. Just get in the habit of doing that every single time you see it. Great. All right, so hoping that just watching me go over these few examples here help you in some way, when you're asked to express the square root of a negative number as some real number times I on your own. And thank you very much for watching.